Okay, so you guys, we're looking at page 51. Just a reminder, ready, Tay-Tay? What are we calling this thing?
Asymptote.
Oh, what kind of asymptote? A vertical, because guess what? There's also horizontal asymptotes. You know what I'm saying? So how do we remember, or what is a vertical asymptote? How do we get those again?
When the denominator.
Yes, Blake, killing it. When the denominator is 0, every time. Okay, so that's really what we went through here. So, let's go on this guy. Did we do this one?
No.
Okay, great. It said determine the vertical asymptote. Let's do it. What is the vertical asymptote of this one? Yeah, it's always when the denominator equals 0. So maybe you start by writing the whole thing. When does the denominator equal 0? And then we move that 2 over. You guys, let's go graph that. Boop, 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 boop.
Yeah, I was a little heavy. I was 10 pounds.
You guys, make sure that you grab your calcies today. Grab a calculator. And let's go graph this. We're going to use our calculators for sure.
VC, I think it's faster versus I think it's faster.
What do you think my horizontal asymptote is? Anyone have any idea what that horizontal? If you do trace on your calculator, trace and go to the right, look at what those y values are going to. On mine, I'm at I'm at 1 now. I'm at 2 now. I'm going past 2. Anyone have any idea?
3.
Yeah, it's going to be 3. And I'm going to tell you on the next page how we know that. But we got a horizontal asymptote at 3. Guys, does anyone remember what the whole, how to find a whole?
They have to both equal 0.
Well, we have to have the common factor on the top and the bottom, right? Do you agree we don't have any common factors on the top and the bottom here?
Yeah.
So we have no whole. Okay.
Actually, we do have a hole for some reason.
No, we don't have a whole.
Oh, wait.
Here's the last thing I want to teach you today is what makes a y-intercept and what makes an x-intercept. Does anyone remember if I cross that y-axis anywhere, what's my x value? Yeah, isn't my x value 0 anytime I'm on the y-axis? So you guys, so by y-intercept, if I were you, I'd write my x is 0. What about for the x-intercept? Yeah. And then we just got to go plug those in. So if my function was the following, my function was this. If I want to go plug in a 0 for my x, that would get me my y-intercept. So I'm going to say y equals 3 times 0 minus 1 over 0 plus 2. What's my y-intercept going to be? Negative 3 over 2, which is the same as negative 1.5. So my y-intercept, I'm going to go left 1.5, and it has the x-coordinate of 0. So I'm going to go put that on my picture like that. Boom. And maybe I'll even note that it was negative. I'm sorry, my y-intercept, you guys. I'm wrong. He said, you're wrong. He's not wrong. I am wrong. What do I have to do if my y is negative 5? Go down negative 1.5, right? My bad. Beck, did I mess you up?
No.
My x was 0, my y was negative 1.5. What about for a x-intercept? If my y is 0, you guys, isn't f of x just fancy for y? Okay, my f of x is just fancy for y. Tatum and Mace, if you need any help later. If my y is 0, I'm setting this whole thing equal to 0. What would you do first? Thanks, Mateo. Say multiply by that x plus 2. What's 0 times anything? Do you want to divide by 3 or do you want to distribute? Doesn't matter to me. Okay? If we did, what would you get, bud?
3x.
Yep. So then what would we do? Add 3. Divide by 3. What's my x-intercept? 1, 0. So I'm going to go on my graph. I'm going to go right 1 and up and down 0. What this has done for us is it's given us our blueprint. Okay, it's given us our blueprint because we know what the graph looks like. This just tells us how to graph and how to follow, what to follow. So do you guys agree When we graph this, we can say, okay, we got to hug this vertical asymptote, go through that y-intercept, go through that x-intercept, hug the other horizontal asymptote, and then I can just hug these other vertical and horizontal asymptotes because there are no points that I had to go through there. We're going to go take a peek at this one real fast. Let's all go type this into our calculator so we just have a general idea of the shape. So we go to our y equals screen. We're typing this in 6x squared plus 10x all over 2x squared minus 6x minus 8. Anyone have an idea? First of all, for us to figure out our vertical asymptotes, we've got to go factor. What are we going to take out of the top, you guys? Let's take a 2x out of the top. What's that going to leave me? 3x plus 5? Okay. What about on the bottom? Yeah, can I take something out of the bottom? What's the GCF of the bottom? 2. When I take that out, toot or toot now? Just toot, which is so much faster. So I'm going to bring that 2 down. What multiplies to be a -4? Adds to be a -3.
-4 and 1.
Agreed. -4 times 1 is -4. -4 plus 1 is -3. So I'm going to say x minus 4, x plus 1. We have factored my original problem. I've not changed it at all. I've just factored it out. So where would we say our vertical asymptotes are? Our vertical asymptotes, again, are where that denominator is 0. -1, +4? I love it. So you guys were going to say x is 4 and -1. We got that. X is 4 and x is -1. I'm going to go right 4. I'm going to go draw on my vertical asymptote. X is -1. I'm going to go draw it in. Let's go find those x and y intercepts. Write yourself a little reminder. An x-intercept is when the y is 0. It's when the y is 0. You guys, if I were you, I would just go back to this one for our everything. Don't go up here because then we're going to just have to factor again. This is already factored. Wait, good call though. Does this create a hole?
Yeah.
But,
Kind of.
right, a hole is where a hole, they would have to be common factors, meaning like an x plus 1 and the x plus 1. We'd have to have it at an actual x value. This is just a coefficient. So this guy doesn't matter for us, okay? Sorry, I should have specified that. Thanks for bringing that up, buddy. So my x-intercept is when my y is 0. You guys, if I put a 0 in right here, and maybe we draw an arrow. I'm doing my x-intercept. I put a 0 in over there. You want to leave the 2's or you want to keep them canceled out? I don't care. Just leave them. Okay. We're going to leave them. So we're going to say 0 equals 2x, 3x plus 5, over 2, x minus 4, x plus 1. What would you multiply by first when this whole thing's equal to 0? Yeah, and even the 2. I'm just going to say, I'm going to multiply by that whole denominator, so the whole thing is gone. 0 times the whole denominator. Yeah, so if you guys start noticing, every time we look for that x-intercept, do we care about the denominator ever? You could always just set the numerator equal to 0 every single time. Are we going to remember to do that? Maybe not. So it's fine to go through these steps. But when does this numerator equal 0? When does 2x equal 0? I'm going to kind of draw an arrow. We're saying when does 2x equal 0? When does 3x plus 5 equal 0?
0.
Yeah, when I divide by 2, we get 0. Nice. And he says I'd subtract 5, and I would divide by 3, and I'd get -5/3. Awesome. So those are my two x-intercepts. 0, 0, -5/3, 0. So let's go plot those points. 0, 0. Let's go put that on our graph. -5/3, 0. I'm just going to go to the left 1 2/3 and then go 0. Again, I'm just guessing. How do I find a y-intercept? Yes, sir. He says, all right, on this one, just my x is 0. I think that these are a little easier because we can just plug in my zeros for x's here, 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 and here. If I plug in a 0 here, wouldn't I get 0 on top? Okay, if I plug in a 0 on the bottom, it doesn't matter because I have a 0 on the top, but I'd get 0 over a -4. 0 divided by -4 is still 0, right? So we're going to say we'd have 0, 0. When I plugged in a 0 for the x, I got a 0 for the y. And we already knew that that was one of our points. Okay. The last thing I want to do is this silly horizontal asymptote. As we look at the graph, anyone have any idea if I trace what my horizontal asymptote's looking like? We do, because if you do zoom out and hit enter, it should show you. So when we looked at that on the graph, the horizontal asymptote is 3. So let's go put that in our picture. Y is 3, horizontal, but a y is 3. Then, are we comfortable with sketching our graph now that we have this blueprint? I'd say yes. Anytime we've got a vertical asymptote, I'm just going to hug the vertical asymptote, go through that x-intercept, and then hug the horizontal. I'm going to put this in a different color. And I'm looking at my graphing calculator when I do this just to help me get the general shape. So that was a horizontal asymptote. Then I'm going to hug this again. I believe, did it go like this? So what the graph?
Other way.
Oh, other way. Get with the program. Okay. Here we go. I'm going to go like this. Hug. Go through. Hug. Never cross a vertical asymptote. Guess what you can do? You can cross a horizontal asymptote. You sure can. And we'll go over that. And then I'm going to do over here. It looks like we just hug and hug. Asymptotes, you're always going to hug them. You're going to get really close. What I just shoved down your throat was a lot. We just went through like a lot. So let's just try it. We're going to just practice this concept. Let's try this guy. Oh, wait. We got to determine how to figure out a horizontal asymptote. You guys, notice on this one, Leva said my horizontal asymptote was 3. How could we get a 3 here?
6 divided by 2.
6 divided by 2 is 3. Interesting. Let's pop up here real fast. Horizontal asymptotes, they can or cannot be crossed. They can. Horizontal asymptotes can be crossed. It's the vertical asymptotes that cannot. Let's just write this on our page. We just said if we had 8x squared plus, I don't even know what it was. Let's say 9x minus 6. I don't care. And then we had over a 2x squared minus 7x plus 4. I don't even care. What do I care about?
The square.
I care about the squares. I care about this part. When I am left with, what I would say here is we have a horizontal asymptote at 8 over 2, which is just 4. This would be my horizontal asymptote. Okay. Textbooky. If this was the equation I gave you, do you guys agree that these had nothing to do with my horizontal asymptote? Nothing. It was those biggest exponents. When those exponents match on the top and the bottom, 8x squared over 2x squared, I'm left with 8 over 2 is 4. Beautiful. How would I write that here? If the degrees are the same, if A
equals B.
careful, if the degree, the exponent. So in this case, if the n equals the m, in this case, since my 2 equaled 2, then you have a horizontal asymptote at
A over B.
A over B. Very good, Coop. What happens then if the degree in the denominator is bigger? If my m degree is bigger than my n degree, could someone give me an example of an equation that my denominator, and you could even use this guy.
Squared over 3x squared plus x squared.
So wait, the degree just means the biggest exponent on the top versus the biggest exponent on the bottom.
Use this x squared over 2x to the 4th.
So you're saying x squared over 2x to the 4th. Okay, does it matter what else I'm putting with it? No, I'm just throwing anything, but I love here, you made the degree on the bottom bigger than the degree on the top. Let's go type, actually, I'll type this in for you. How about that? I will type this in for you because I love you. I'm going to go type in what Ritzy just said. He said x squared, and then we just threw some other stuff. Plus 2x minus 1, and then we're going to divide that by 2x to the 4th, and then minus 4x plus a 6. Anyone have any idea what you think my horizontal asymptote is now? I think that's a great guess. He's saying, does my y equal 0? Is that what my horizontal asymptote's looking like? Guys, does it look like...
It equals the square root.
Well, every time. So what we've got from this, every time my denominator exponent is bigger, the horizontal asymptote is always y equals 0.
Okay.
Which axis is y equals 0? It's the x-axis. Anytime that denominator is bigger than 0,
You do not.
we have a y equals 0. Oh, I'm sorry. I was just reiterating this guy. Anytime the m is bigger than the n, we're going to say we got a horizontal asymptote at 0. Yeah. Okay, wait. Now, Cooper, I know what you're saying. If the degree in the numerator is bigger,
You don't.
let's flip it. Can I take what Mr. Ritzy gave me before? How would I change this equation to make the degree in the numerator bigger?
X to the 4th and 2x squared.
Could I even say x to the 12th
Yeah.
and be obnoxious? You guys, does this look like it has a horizontal asymptote that it follows? Nope. So anytime that degree in the numerator is bigger. So if we were to say like x to the 12th plus 2x minus 1, don't care about the other stuff, over 2x to the 4th minus 4x plus 6. If the degree in the numerator is bigger, we just don't have one. It doesn't exist. So now let's put it in action, people. Let's put it in action. Whew. Right away, looking at this first one, I'm going to kind of keep our little table up here. Where is the degree bigger? Yeah, I've got an x to the first on the top. I've got an x to the second on the bottom. Since the degree on the bottom is bigger, what are we going to say my horizontal asymptote is? 0. What's up, Mateo? Mateo asked a great call. He's like, hold up. We factored this thing. Mateo, do you still agree? Even if I distributed this through, this is still a 3x squared here. And on the bottom, this would still be a 2x squared if I distributed it through. So if it is given to us factored, we do need to still kind of distribute it through to see what those biggest exponents would be. Great call, Mateo. Okay, you guys, we got a horizontal asymptote at y is 0. Let's go plug it in. Let's go draw that. Awesome. Vertical asymptotes. You guys, we got to go factor this guy. Let's go factor my ridge. What's the top doing? Any GCF or anything?
Nope.
Nope. What's the bottom going to factor into?
X plus 3, x minus 3.
Love it. So do we have any holes? Nope, because I don't have any common factors on the top and bottom. Notice I didn't leave you a blank for it. Vertical asymptotes.
X equals 3 and x equals
3 and negative 3. I love it. And thanks for saying x equals, because that tells us the vux and that they're vertical. Let's go to our picture. And let's go put a vertical asymptote at 3 and a vertical asymptote at negative 3. Okay, how do we find that x-intercept again? That's
Easy,
when
set
the
y to 0.
y is 0. You guys, that's when my y is 0 here. Do I want to set the whole thing equal to 0? I could, but what are we going to get to? It's just going to be 0 equals all this. We're going to multiply by that denominator. Can I just do 0 equals the x plus 4? For the x-intercept, for the x-intercept, you only have to worry about the numerator because the denominator is going to cancel out when we multiply by 0 anyway. What's my x-intercept going to be? Negative 4. So that's my x is negative 4 when my y is 0. So I'm going to go to my graph and I'm going to say 1, 2, 3, 4. Boom. It's on the horizontal asymptote. That's crazy. That's okay. You can cross a horizontal asymptote. How about my y-intercept? How do I get that guy?
You set x to 0.
That's it, Coop. Thank you, sir.
But it's undefined.
What? If I put x is 0 here or here, won't I get 4 on top?
But
And negative 9 on the bottom? So when x is 0, my y was negative 4/9.
okay.
You got it. So I'm going to go 0. I'm going to go down 4/9. Yeah, I'm going to go about halfway. Guys, we're estimating. That's all the blueprint I have. Then I'm going to go type in this into my calculator just to make sure that what I have kind of matches their blueprint. So x plus 4 over an x squared minus 9. Does this look like it can fit our restraints? So here's what I'm going to do. You guys, what this means is we need to, I'm going to go with pink. I'm going to follow this horizontal asymptote, vertical. Guess what we have to do? We have to cross through, and then I'm going to hug my horizontal asymptote. But this shows we have an x-intercept here, so I got to cross through it. Then what am I going to do right here? We're going to hug, guys. We're going to hug the vertical asymptote, go through my y-intercept, and I'm going to hug my other vertical asymptote. Am I going to lose sleep if y'all aren't as square as that graph here? No, it's fine. You're just following our little specifications. Anything that I got to follow over here, can I just be like, whoa? Sound good?
Wait, okay.
What you gotta get?
Okay, you guys, let's take a peek at this guy. Can I factor it at all? A cannot factor that, right? So this is what we're dealing with. That horizontal asymptote. You guys, if I graph this for you, because I'm an angel and I'm going to graph it for you, if I've got, here's my graph, y'all. Does this look like it has a horizontal asymptote? It doesn't look like it, right? You guys, would we have known that? Look at the exponent on the top. It's bigger. Whenever that exponent on the top is bigger, we have no horizontal asymptote. Okay. Let's go to that vertical asymptote. A vertical asymptote is when the denominator is 0. When is this denominator going to be 0? At 0. So I want you to write it as x is 0. Now, you guys, this is a lot to remember. This is literally has 5 different things I want you to put. Write these little hints down. If you're forgetting how to get a vertical asymptote, write that down. Why do we have no horizontal asymptote? What can we write with this? Thing. I hate that word. Yeah. So we could say numerator degree was bigger than the denominator. Degree. Agreed, bud. So if you come up to me later and you're like, how did you know that? It's because I wrote down little hints along the way that you guys should be too. Whole. What gives me a whole? Common factor in the top and bottom. Do we have any of those? No, we couldn't even factor that at all. So there's no whole. That's fine. Let's remind ourselves how we find that x-intercept. That's when my y is 0. What do we actually care about? Just the top. Guys, every time it's just when the top equals 0. So I'm going to say, when does 5x squared plus 3 equal 0?
Square root of 3/5.
Not quite. What would you do first? Wouldn't you subtract 3 first? Well, we would divide by 5. So we'd have negative 3/5. Guys, when we take the square root of a negative, does that make you think of Mr. Richards? Square root of a negative is going to be an imaginary number. Guess what we don't have to do any of this year?
Imaginary number.
And we don't have to do any imaginary numbers in AP Calc either. Hallelujah. So you guys, do I have to worry about an imaginary number? Nope.
No,
I'm going to
they're
literally say
imaginary.
none.
They don't exist.
They don't. We don't have to worry about any square roots and negatives.
It's just your imagination.
How about a y-intercept? It's when my x's are 0. Beck, talk to me. He said, wait, if I'm plugging in a 0 here and here, Beck, I'd have 3 over 0. Am I allowed to divide by 0? Yeah. So you guys, how many y-intercepts do I have?
Undefined, so
None. This seems like the lamest graph ever. Literally all we have is a vertical asymptote. Would you say, based on what you're looking at in my calculator, that that looks about right?
Yeah.
So what I'm going to do, and I'm going to go, in a green pen. I'm going to be like, okay, I'm going to hug, and I'm just going to go. And then I'm going to hug, and I'm just going to go. Did I really just wing that? Yes, I'm fine with it, you guys. Make sure that you never cross that x-axis. Make sure that you never cross that y-axis, because we had no x and y intercepts. There are no holes, and there was no horizontal asymptote. Yeah, this is kind of the best. You guys, correct me if I'm wrong, we've already factored this stuff and found holes. You down Livingston Sanders's? You guys, just a reminder, how do we find this hole? Why do we say negative 3? We had an x plus 3 on the top and the bottom, right? How did we get this? We plugged it back in once we canceled this out, right? So the reason why I've already taught you this is this now is what we use for all of this stuff. Check this out. Mateo, would you agree we started with a 1x squared over a 1x squared? Who wants to remind me what that horizontal asymptote would be then? It'd be 1. But Mateo, what if we factored it and we canceled out our whole? Would 1x over 1x still cancel out to be 1? Yeah. Love that. Thanks, Mateo. So we're going to say my horizontal asymptote's 1. You guys, let's go put that in my picture. Let's go find that x-intercept. Find my x-intercept. What am I plugging in for what?
0 in for y.
0 in for y. You guys, plug it in here. Do not go back to what you started with. Always go back to here. If I plug 0 in for y, what am I really going to write down? 0 equals just the numerator, right? Isn't that our little shortcut for this guy? If 0 equals just the numerator, what's my x-intercept? -1 is my x. X-intercepts are always a point, so I'm going to say my x is -1. I got that by plugging in 0 for my y. And I'm going to go plug that in. I'm going to say, boop. I'm going to go put that on my graph. -1, 0 is right there. That y-intercept. Here we go for that y-intercept. That's when my x is 0. You guys, don't plug it in up here. Go right here. If my x is 0, what would we be left with? Yep. My x is 0. I'm left with a -1/2. I'm going to go plot that. 0, -1/2. That seems like a lot going on. I'm going to go to my graphing calculator. I'm going to go type in my OG just in case I did something wrong when I factored. X squared plus 4x plus 3 over x squared plus x minus 6. This is what my calculator is saying. Why do I have this dot? I don't know. You guys, does this look like it's fitting our specifications? Yeah. So you guys, here's what we're going to do. We're going to hug. We got to go through the hole. We got to go through my x and my y-intercept and then hug the other asymptote. I'm going to do it in a different color. I'm going to go in green. Boo! Through the hole, through the intercepts, hug. Then, do I have anything that I need to follow on the right side? I'm just going to hug the asymptotes. Bless you. You guys, I already gave it to you factored. So, Mateo, I gave it to you factored. We crossed out our hole. You agree the hole is going to be at 4. Then we wrote what was left, x plus 1 over an x and an x minus 2. I plugged that 4 in here, here, and here, and I got the hole was going to be at 4 5/8. We put it. We found our vertical asymptotes here when my denominator was equal to 0. Horizontal asymptote. Be careful. Do you think that this is going to be, what do you think it's going to be? What's my exponent on my bottom? Tatum, you with me? Exponent on the bottom is x squared. Exponent on the top
X.
is just an x.
So it's 0.
It's 0. Anytime the denominator exponent is bigger, it's going to be y equals 0. Now, Mateo, if I would have looked at the beginning, don't you agree I would have had an x squared on the top and an x cubed on the bottom? So even before I got rid of the hole, the denominator was still bigger. Love it. Okay, yeah. Okay, x-intercept. Let's go find it. So my y is 0. You guys, everything gets based off of this. I'm going to, everything gets based off of this. Don't go to the original. If my y is 0, what are we going to say my x-intercept is? Yeah, we only have to worry about the top, you guys. 0 equals x plus 1. My x-intercept would be a -1. So I'm going to put that as a point. -1, 0. I'm going to go plot that. -1, 0. Oh, I should do my horizontal asymptote too. We said my horizontal asymptote was y equals 0. Hoi, horizontal. I'm going to put that in there as well. My y-intercept. My y-intercept is when my x is 0.
We have none.
Ooh, kind of goes back to what Beck was saying. If I plugged in a 0 here, what would I have up top? 1 plus -2 times 0 is getting me a 0. I'd have a 1 over a 0, which is undefined, which does not exist. So that's kind of my blueprint. Let me go graph what I've got. If we've got x minus 4, x plus 1, and we got that over x minus 4 again, and an x minus 2. Does this look like it's fitting ours? Cool, 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 cool. Look at this. We've got a cross. So check this out, you guys. When we go to graph, we're going to hug. Let me get a different color, make this clear. We are going to hug this vertical asymptote, go through my x-axis, and then I'm going to hug that horizontal asymptote. What about this cute little loopty-swoopty? What am I going to do with him? I'm just going to go like this. Woo! Don't be crossing that x-axis because it doesn't have any x-intercepts. I don't really care how specific. Yeah, Mateo?
How come it like starts our point at the bottom?
Oh, I don't know. That's just my free calculator. I don't know why that is labeled and that is labeled. No idea. Thanks for asking. Here, you guys, your calculator's not showing you the hole, but we know we've got a hole. So I'm going to go through it like that and hug the asymptotes. So let's just try page 58 and note that we want the vertical asymptote and y-intercept there.